Hello. So first off, I'll be introducing some machine learning models here and a little bit AI here, and how would we implement that in real world situation? All right. I guess we all know, in the by the end of the day, we need to implement technology at our daily life, right? Okay, there we go. So this is one of the example here. So first off, I'll be running this code here, and I'll be just showing you some example here. Good. All right, and
Mhm.
why you can also open up your camera. So therefore, I'll be knowing what you are doing. Okay, good. Let's see. All right, so this program is Monte Carlo's simulation. So everything is basically right here. So this is Monte Carlo's simulations here. And this is basically the formula, and we also have some demonstration in the future. All right, okay. There we go. Good. Okay, so all of these, okay, I also customize this code a little bit, therefore I'm able to get what I really want here. So first of all, I'll be checking who could you please give me a stock tinker's name? Anybody?
DJT.
DJT. Okay, DJT. Oh, that's a Trump media, right?
Yeah, yeah.
So let's do it. Let's do it. Okay. Let's see what is going on here. Okay.
Oh, his revenue's been going down. Fortunate.
All right, there we go. So this is the 100 time. No, this is 80 times. This is a number of a simulation 80 times, and in the future 252 days. So overall, I guess this is a density function basically. So
Probability density?
yeah, this is density. Um, Probability density, which is PDF. Okay, so this is like a little bit PDF. PDF. PDF is a probability density function.
Function. Yes, you can use statistics to operate.
Exactly. So as you can see right here, the
What?
density is very low. That means it's the least possible to happen, right?
Yeah.
And
So
right here,
it's
this
less
is
likely
yeah,
because
most of
it's
the problem. Yeah,
so you
exactly.
would average out all the simulations within like a specific number of trials, right?
Exactly.
Okay, and then you would use the probability density to calculate the expected return on the stock if you buy it right now.
Correct. That's
Okay.
something like that. So this is the Monte Carlo simulation.
So
So
you can
we're
just reduce stocks to statistics. I see.
yeah.
Oh,
Okay, so this is very interesting and I would say it's pretty fun. I mean, you can implement some statistical model by using computer science and predicts the stock market future. Well, definitely, probably you can make some money from it, right? Okay, there we go. So this is 80 simulations here. This is 80 simulations. I also customize this program a little bit. So which is top lo-fi prices, which is like a pink sheet, right? Which is less than $1. The top five high prices could be $800. And also I customize a medium prices, which is $26. So therefore, definitely you can customize it by your own desire for example here. So this is basically top five high. I can change that to top maybe 10. So all I need to do just change that into 11. It will give me whatever I want here. As you can see, you do need the for loop, right? Okay, so this is a very basic computer science. And let's maybe try more simulation. Maybe fewer. Let's try maybe 50 or maybe 20, maybe one. Okay, let's try one. All right. Okay. So then we'll be seeing just the one single line here. All right. And then do we do you want to use the same stock tinker or try a different stock? Hello, everybody.
I don't know many stocks, but let's go with Tesla, TSLA.
All right, let's go Tesla here. Okay, so just the one single line here. All right. Okay.
Yeah.
This one predicts the one path. All right. So it's basically these. Okay. And I guess one simulation doesn't make too much sense.
Yeah,
Usually,
why does it have one?
You can modify this one into one, right? Yeah, I can modify that into 50. So there will be 50 simulations here. Okay, and let me run this code real quick and the Tesla as well. Let's see what is going on here. Oh, somebody's knocking the door. Let me see who's over here. All right, there we go. So then we have this 50 simulations here. Thank you. So we have pizza here. That's good. Could you please place on the table the cup? Yes. All right. Thank you. Yeah. That's Alex. And then we have some pizza here. Hold on for a second. Let me. Okay, where's? Okay, there we go. Do not blur. Wait a second. Wait a second. All right, we have pizza here, right? So later on, everybody pick one. Okay, good. Uh, yeah, let's keep back. Okay, there we go. So this is the machine learning. This is the machine learning and AIs here. So as we can see, if you are able to master machine learning, you can do a lot of practical stuff, right? Okay, such as stock market prediction. Um, and let's maybe try another one. So let's try Apple, all right? Okay. Okay. APP. Oh, wait a second. What's Apple's wait a second. Let me try another one. Maybe Meta. Okay. All right, there we go. So based on this chart, what message did you get?
It's usually gonna go up most of the time.
Most of the time, right? Okay. So because the density is something like that, right?
So how accurate is a Monte Carlo simulations?
I would say a lot of trading company, financial institution, they're using it. So like a Wall Street,
So this is what quants do.
it's a quant, yes. So this is a quant, exactly. Uh,
Let's see if it was this easier.
yeah, good. Okay, so this is one of the example here. Okay, and then let's maybe dive into some basic algorithm stuff here. Maybe I'm going to show you this one. Okay, this is basically a calculus, the calculus model here. Okay, import these and give a range A to B and that. Okay. So this model is basically a Riemann sum. All right. So first of all, I plug it in a formulas here. So this formula, I guess it is x squared, right? Okay. X to the power of 2 and return f itself. Sigma is basically summation process, right? And if you put everything together, you get, well, this is a parabola, right? Okay, x equals y equals x squared. And all of these bars below the curve is the area of a certain range. If you cumulate everything together, it gives you the what? The area under this curve here. So it is also called a Riemann sum. Okay. Anybody, any question in terms of these? No, I guess. Okay, good. Okay, so next one, I guess probably I'm going to just go over this Monte Carlo simulation a little bit. All right, okay. For these, you can find this anywhere else in the internet. Okay, but the most important thing you got to know where to implement it. All right, okay. So, all right, the basic of Monte Carlo methods, probability density function. I mentioned that before, right? Okay, so it's a PDF, probability density function here. Most likely you'll be learning these, I mean, officially learning these at a college level, probably sophomore or junior, especially as the upper division. Okay. And of course, mean, variance, standard deviation. Um, so could anybody tell me what is mean? What does mean? What is mean?
Mean is the average expected value of the simulation. Essentially, it tries to predict within a statistical sampling, like what is the true mean of the actual data when you collect it. It's like what's if you roll an infinite number of times, what is the average value that you'll get?
Good, exactly. It's an expectation. Good.
Yes.
And how about standard deviation? I know most people don't like it. Okay. Tony, yeah, you mentioned that, right?
Standard deviation is really just a measure of how spread out a data point is from the normal distribution. It basically is you take a data point and then you take the distance from that data point to the mean and you use a formula that basically I think it's similar to the distance formula at least.
There we go. Exactly. So it's basically the range away from the mean. So
Yeah.
in
It's the average of the average of the data points is each data point is spread from the mean.
exactly. Good. In terms of finance, standard deviation means risk.
Oh,
So that makes sense, right? Yeah.
yes.
Because expectation is, for instance, suppose I'm going to invest a Tesla, right? I have expectation such as $400, right?
Yeah.
So standard deviation is basically it could go up, it could go down, right? That is
Yeah.
spread out, right? So that is the standard deviation. So most likely quant, we're working on the standard deviation a lot because that's the risk, right? Okay, you
Yes.
could earn money or you could lose money. That's the standard deviation. Yeah, good. And two Monte Carlo practical transport example here. So decay in flight, right? Okay. I guess we mentioned the Windows blue screen in airport, right? Okay, decay in flight and competence scattering stuff here. Okay. Um, and boosting simulation. All right. Simulation. Okay. So variance reduction techniques here. Good. Okay. Good. And there's just a lot of interesting stuff here. I highly recommend everybody work on this a little bit. So even though this is a high level um, computer science, statistics, and mathematics, but I guess it's not that bad, right? Okay, unless you understand the foundations, this this stuff is just you just need more time to work on it, right? Okay, so quantum field theory, okay, particle physics, okay, and all of the molecule molecular modeling, okay. So this is a little bit chemistry, okay. So as we all know, so a regular protein has how many combinations here? I mean but most likely it's a 10 to the power of 400, right? Okay. So regular computer couldn't do that. So mm, yeah. And that's,
So use AI to predict it.
yeah, we were using AI to predict it. It's basically we just cut off the least likely uh, um, samples or least likely occurrence. Most likely we can ignore probably 50% and we just work on the other 50%. So that would sufficiently increase our working efficiency, something like that. That's very good. And also semiconductor devices, absolutely, right? Okay. And light transport calculations, traffic flow simulations, environmental science, and the financial market simulations. Exactly. So I guess we just did it, right? Which is this guy. Okay. Um, and optimization problems here. So it has just a wide implementation in human society, right? I guess by the end of the day, we just want to we just want to implement technology at our daily life, the very basic stuff, such as maybe transportation, cooking, right? And maybe do some basic stuff, right? Okay, good. And right here is basically some formulas here. Okay, numerical integration. Okay. I guess I mentioned this summation before, right? Which is the sigma here. Okay, the summation process here. Okay. And as you can see, this is this a discrete model or this is a continuous model?
It's stochastic, so it's probably discrete.
Is it discrete? There we go. Good. Um, very good. Okay. And then we have some interesting and fun reading assignment here. Okay. And these. And by the way, all right. So this is an interesting story. Okay. Most advanced formula is, I mean, are generated by royalty. It's like rich people. Oh, why? It is because, let's see that. So drop a needle on a line, the sheet of a paper, and determine the probability of the needle crossing one of the lines here. Well, I mean, for most people, this is such a waste of time, right? Okay, why you are why you want to know these, right? I mean, however, okay, rich people or royalty, they don't worry about, I mean, their works, right? They have spare time to work on these stupid stuff. However, this is not stupid. This is a very, very important stuff. And then you can see if you think this is stupid, well, I don't think so, right? Okay. So the message is this, okay. Sometimes you just want to, I mean, I guess you want to think stupidly, right? You want to do something stupid or something, uh, something not very how to say that? Something not very I mean, from other people's perspective, it's not worthy. I mean, for most people, this is just useless, right? But I mean, eventually he invented this formula and possibly changed the world, right? Especially AI and simulation process. And the message is also, uh, if somebody if somebody laughed at your work, just let them laugh at you, all right? I mean, you just keep doing your job. And I guess eventually one day you will succeed, right? Okay. So, yes. There we go. Okay. And this is some examples here. Well, actually, it is very important. It is very important. Yeah. Okay, good. And then, all right, I guess probably let's maybe dive into some use lead code problem here. Okay, good. Um, let's see. I guess I guess we want to maybe work on the three sum again. So that is such a interesting and good question. Okay, there we go. All right. So I'll be demonstrating these solutions once again. All right. So this question, all right, okay. So you're going to find three numbers in an array, right? And those three numbers, the sum is going to be zero. And definitely in most of the time, it's there should be negative numbers here, right? Okay. So for this question, all right, there's many ways to understand that. So one example is you are working on a three-dimensional coordinates, right? Okay. You have X and you have Y here and you have Z here, right? Okay. And basically you can project three dots here, right? So this is one dot here. Okay, I'm using a different color here. And another dot is on the Z plane, right? And you just line them up. And eventually this is a vector, right? If we studied physics before. So this is a vector. So basically the V1 plus V2 is V3. And we also have another vector here, which is a Z1 here, right? Okay. And what we really want is basically V3 plus Z1 equals 0, right? It's basically there are three different forces, I guess, and they are canceling out each other. Okay. So this is in math. In math, we can also understand that by set theory. So which is basically x intersect y is equals to empty set, right? Okay, something like that. And of course, z and y is empty set. Okay. And beyond math, this question can also be understood by physics. Okay, so for instance, in physics, we have we have a box here, right? So let me draw a box real quick. Okay, there we go. And I'm going to drop three forces here. All right. So one is gravity, and I'll be dropping two more forces. Okay. So one is a support force. And this one is a friction, basically. It's a friction, right? Okay. So I'm going to call this is F2, and this is F1, and apparently this is G, right? Apparently this is G. Okay. So I guess we all know the formulas here, right? So we want to have F2 plus F1 and equivalent or equals to G. If this is true, in terms of physics, what is that?
Well, the net force is like equilibrium, so there wouldn't be any net force acting on the object, and therefore it would move at a uniform speed or stay at rest.
So it's a stationary, right? Good. So
Yeah.
that means it's a stationary. That means a stable or static, right? Static. In the most of the times we want a stationary or stable. Am I able to change this? Probably yes. Stable. Okay. Most of the time we want a stable status, right? Okay. Such as what? When you are filming something, right? Do you want shaking? Do
No.
you want? No, you don't, right? You want stable, but usually people will shake, right? Okay. So this formula is able to support filming process and reduce shaking, the vibration stuff. It will be keep using this model to correct. It's like a correction process here. There we go. Good. Okay, so now since we understand the physics here, so this question turns out to be okay. We just need to do what? Okay, we just let's see this one. Delete these. I'll be just placing another force here. We just need to find the sum of these two force, right? Okay, and for instance, this purple line here, right? Okay, this one equals to that. If that is true, all right. So it's a stable. Okay, we find the perfect balance here, right? Okay. So the fundamental idea of this question is to create an algorithm to stabilize a certain state, right? Okay. So does this make sense to everyone? This all right, good. Okay. So now let's dive into the programming step here. So the most naive is basically using the simulations, right? Okay. So for instance, this one, and I guess we need to, I don't think we need to sort, but eventually we need to sort, right? So for I in range and 0, this is n minus 2 here, right? Okay. And then I guess we just need just more stuff, right? Okay, and for k in range, this is j plus 1 and n here, right? Okay. And what do we need here? So if statement, right? Okay. So if what nums plus nums and plus nums, if that is equals to 0, right? If that is true, it is going to be what? That is one of the example here, right? Okay, so we are going to have a result here. Okay. And then we also need to push it here. So inner equals another data structure right here. So this one is going to be what? This one is going to be I, and this is a J, and this is a K, right? Okay. And if that is true, what do we need to do? So we're going to append all of these three numbers in, right? Okay, there we go. Here, copy this. For these, I highly recommend everybody just a copy and a paste because it's just redundant and it's just repeating stuff, not fun. Okay. And we also need to sort it because we don't want to have the duplicate data right here, right? Okay, so for instance, this one's going to just the inner period sort, pretty straightforward here. Okay. And then we also need to check. So for instance, for item, okay, we're in res. Okay. If not, okay, we can simply use some Python built-in method here. So this is a pros of Python here. If what? If something not in res, and then we're going to add in, right? So that is basically inner here. If inner not in res, we're going to do what? This one period append, we're going to append inner in. There we go, good. So overall, this one, I guess it will be working. This is the most naive solutions here. So could anybody tell me what is the time complexity of these?
It's O cubed.
Yes. So this is solution is very chunky here. So n to the power of 3, right? So as you can see, so working efficiency is very important, right? Even though it passed the 3 basic cases here, if I submit, I guess it wouldn't get the full score. I mean, of course. Yes, of course. All right, so time limit exceeded here. So it's almost the full score, but there's something too big. All right, so time limit exceeded, which is a TLE. And in the real world, we want to increase our working efficiency, right? And this is something is too slow, and we want to increase our working efficiency. But this is so-called a brute force. This is so-called the brute force. Okay, brute force. And I can tell you a lot of like machine learning and AI are using brute force. Brute force. Yeah, unfortunately, it's using brute force. That's why, okay, so when I'm working using this algorithm here, right? So this is this simulations here. I need to update this a little bit, okay, and then run this again. So now this 100 times the simulations. I would just study another stock, I guess maybe SMCI here. Okay, as you can see, it takes a bit while. It takes a bit while here, and then you can see right here. It's 17 seconds, probably something. Well, tick tock, tick tock, tick tock, blah blah blah. Yep. Okay, so now we have that, right? Okay. It takes a time. It takes a time, basically. It takes a totally 26 seconds, right? Okay. But just imagine what if I enter 500? It's going to be slow, right? Okay. It's going to be slow. And let me test it. I'll be just testing maybe. Let me try another one. Probably this is going to be Amazon, right? Amazon, right? Okay. Oh, I guess that's auto completion. Good. Yeah, it takes a not for forever, but it takes a bit a while. It's just not fun to see these, right? Okay. All right. So this is a brute force. Brute force is very, I mean, it's naive and it can solve most of the problem for sure, but it's just too slow. That's why we want to to implement advanced algorithm to boost AI and machine learning, right? Okay. I mean, it's just too slow. It's just too slow. Okay, there we go. Time limit exceeded here, right? Good. Okay. So now, okay, hello, Alex Town. Okay. So now I want you to share your screen. So I want you to show us a optimal solutions. All right. Alex, are you ready? Hello. Hello, Alex Town.
Oh, he's here. He was someone knocked at our door.
Okay. Alex, yeah. I'm going to stop sharing mine. And do you want to share your screen and show us optimal solutions here?
Or which one?
The threesome.
Um, wait, what have you like done right now?
The brute force solution.
Optimal solutions, yes.
Did the brute force.
I really don't want.
You don't want?
Yeah,
Oh my God. What are you talking about? Do it. Just do it.
Yeah,
no.
just do it. Just do it.
Oh,
Can you do it?
I don't even know how to do this problem.
Just
Honestly.
do it.
I
Just
haven't done
do.
this program in like 3 months.
Just do it.
All right, hold on. You are good. Derek, how are you doing?
What?
I want you to share our screen. You don't have to open your camera. It's okay. I want you to show us a optimal solutions. All right. Okay.
Show us or like just show or type? Because
Hi.
I have it already.
From 0 to 1. You can use the C++, you can use the Python, any programming language here. Yeah.
I mean, like I literally have it
No
right
worry, no
here.
worry. I'll be walking you through. I'll be walking you through.
I delete it.
I guess you just delete it and do it from scratch. Yes.
I'll try. Okay.
Okay. Talk while you are programming. All right.
Oh, okay. So result. It was set. Yes. Um, for loop and I portfolio. So it is and suit. Smaller than and it's two other increments to left equals one to right equals n minus one. So while yeah, wait, and then x 0 minus no minus one. So while left is smaller than right. Have to declare that and x. And then declare let's say c equals 8. If x equals c, then box back copy and then x if this is x equals and then after this here so s inserted box, so I have to check for repeats and okay. Yeah, left actually right here. Then I think left. Oh, so else else if wait, this is this is that, so uh, oh, not here. Smaller than C left plus I think. Hmm. And then this time sir that's I think. And then I do this again. Hmm. Um, um, I forgot how to do this.
All right. So, okay. Anybody who wants to help? All right, that's good. So let me share my screen. All right. Good.
Okay.
Oops, wait a second. All right, so for algorithm, all right, so the one vital things is you really don't want to memorize the code. You want to use your logical thinking to push it forward. One of those is okay, but you do need to memorize something, all right, such as the proper syntax here. So for these problems here, right? So logically speaking, you can first off you can sort it, right? So 0, 1, 2, and 4, 3. So this is going to be a sample example here. So sort takes how many time complexity? Anybody's?
It takes n log n.
Good. It's n log n here, right? Good. This is the optimize the sorting algorithm here. Good. So first of all, what you really need to do is nums period sort, right? This is something you have to memorize. I mean, otherwise, I don't know, right? I mean, you have to do this here, right? Okay, good. So And then what you need to do next is basically you just need to implement the logic here. So for instance, the algorithm itself is going to be called two pointers, all right? But you need to add another pointer outside. So overall, I guess it's going to be a 3-pointer or something here. So you do need a for loop here. So for I in range, this is from 0 to n minus 2 as well. Good. That simply means you put a pointers here, right? And you also put another 2 pointers from this position and from this position to that position, right? So they are moving towards to each other. Good. That simply means it leads you to make a what? Left pointer here. This is I plus 1. This is R, right, is equals what? N minus 1, right? Okay. So N is going to be the full range. Okay. So why this is I plus 1? Because you don't want to use this number. You want to use the number right next to it, right? Okay. And then you need to make a formula here, x plus y equals z, right? I guess we through the diagram before we agreed that we need like 3 forces, right? Okay. If you study physics, you just use F1 plus F2 and plus G is a 0, right? Okay. And therefore, G is what? G is basically negative or 0 minus F1 plus F2, right? Okay. It's a simple math here, right? Good. And then now what do you need to do? You just define this one here, right? So this is 0 minus nums of I, right? Okay, you have the math formula here. You just write it down, okay, right away. And then what do you do? What do you need to do next? Here's while loop here, right? Why you need a while loop is because these are 2 pointers, basic structure, right? So for these you have to memorize it. So when L is less than R, that means, what does that mean? That means L left doesn't cross right, right? So they didn't meet each other. So then that means they're still searching something here, right? And in terms of that, what do you need next is now I guess you need to make the very first comparison, or you can also define something here. So C is what? C is nums plus something, nums plus num something here. And apparently this is L and R, right? Because you are finding two numbers here, right? So this is basically, well, this is F1 plus F2, right? Okay. And then you just make a comparison here. So if X or this is a G, right? If a G equals a C, right? Okay. That simply means what? That means they're canceling each other, right? So that is a jackpot. So you want to push it into the whatever the data structures here. So this is going to be this. And for that, I'll just copy it and paste and paste. And then this is L, this is R, right? Okay. And you do not put G here, right? Because this is a value, not index. So I saw that you put X over here, and that is not going to work. But you can do that. You can do this. You can do this. This is okay. This is okay. Good. All right. And then okay, if this is true, right? So yes, we also need to define the box here, right? So box is going to be a list here, right? Okay. All right, there we go. So now we have that. And then what do we need to do? So since we sorted it, right? So I guess we can add it to the rest directly, right? So append box here. And then we have else if, okay, else if what? Remember the physics, right? So if a C is less than G, what does that mean? If C is less than G, that simply means the non-natural force is too small. So the whatever the car or whatever the object is going to slide down or go up. Anybody? So remember, the physics, right? So this object is going down or is it going up? Oh, hello, Thomas. What do you think?
I'm sorry, could you please repeat the question? So if it's less than, will it slide up or down? Like if the force is negative?
Yeah,
If the force is negative, it will slide opposing to the direction you attribute as positive. So you say that up is down and the force is negative, then the object will slide down.
exactly. All right. So that simply means you are parking your car on the uh, on your curb, right? Okay. I mean, you don't want that car um going down, right? No, you don't. So you pull the brake, right? Okay. There we go. So in terms of that, so what do you need to do right here? So you need to increase the force, right? And how would you increase the force? You push the left pointer forward, right? Okay. And else is basically you is the force too big? It's going up, right? Okay. It's anti-gravity, which is anti-gravity force going up, right? Okay. So this is -1. Because we always want to keep the system balanced, right? So this is a system balancing uh, process, right? Okay. So it will always keep it stable. Stabilizer is a stabilizer here. Good. Okay. And you also need to do what? So you also need to, no matter how, you also need to push this one forward and this one leftward here, right? Okay. Because you are managing these two pointers, right? You're managing these two pointers. Okay. And then, all right, so overall, as you can see, you only have two loops here. So it is possibly just the what? It's n squared, right? Now it's n squared. Which one is smaller, squared or cubics? Squared, right? Okay, there we go. So now okay, we are using some optimized solutions here. And then, all right, so, and then if we return res, I guess we're going to have some better result here, but it's not good enough. Okay, it's not good enough. So right here, I guess, we also need to do what? We also need to probably, let's maybe round this code a little bit. Okay, so let's see what is going on. Well, there's something here, G, where is the C? Okay, if else, if C is less than G, I have the G here, the runtime error here. Okay, else if this one. Okay, around these. Oh, wait a second. Why it doesn't work? If here, runtime error here. Invalid this. If C less than G. Next line, L plus 1. And let me just remove that. Let's see that. Oh, still. If this one. I have G. G is here and C is here. Let me round these a little bit. I think this one shouldn't be a problem. C less than G. I have C's here. And this one plus this one less than 1. And okay. Yeah, sometimes the Python's indent problem is pretty interesting. Oh, you know what? It's okay. Because I forgot to declare res here, right? Res, and I use these here. I guess it caused the problem here. So I do need this one here. And let me run this code here. Then it should be still, okay. -1 plus 1. This one, the system balances here. Okay, let me remove this one. Only keep these. This one. Okay. Right here. I guess now I guess it probably is some indent problem here. The while loop here. I have n here for okay, num sort. These ones these, and these ones that. Oh, these one are. Oh, you know what? Okay, I made a stupid questions here, a stupid mistake here, which is very easy to fix. This is the left, and I'm using L and R. I'll just remove the left and R here, right and here. So it's a spelling problem here. Good. Let's see what is going on. A runtime error. I think still these. Okay. Runtime error still these. Okay. This bug is kill me L if I have R and that's ILR append box here. The box is these, C equals these, and this one is that. And what else? Okay. From here, then is these, num is a sort, and the rest equals these. Okay. Run it. Okay. Let's see the runtime error. Still. I have this one here and this one here. C less than that. Okay. Again, let me remove this one. Let's keep trimming this a little bit. Okay. Okay, now I have this. For this I really don't understand. So okay. L if, right? C less than. Where is my C? C is here. C less than G and L plus 1 and L's R minus 1. Let's do that again. Still runtime? Okay. G is this. C is this. Okay, come on. I really don't. C less than that. L if. Wait a second. I didn't see anything wrong with this. Okay. Could anybody see what's wrong with this code? I didn't see anything wrong with this.
What's a runtime error?
The error is like invalid syntax, but this is a decent syntax, right?
It's indentation error because the L plus equals to 1 is not the LF clause L plus equal to 1 is not indented in the if statement.
So let me.
You can't have any non-indented blocks before within but in between the if and the elif statements.
Yeah, that
So
makes.
you must remove the L plus equal to 1 after the elif if you want it to work that way. Yeah, or that if the logic goes. That should solve it.
Yeah, let's see. Let's see this. Okay. But if I do these, okay, so it's the wrong answer. So I do need this one here and here. Otherwise, I can remove these. Okay, let's do that. Yeah, sometimes the Python, the syntax is just a little bit weird. C++. Okay, so this one must be else if. This one must be else if. Otherwise, it wouldn't work. How am I able to maybe move it to here? No, I don't think so. No matter how, no, it wouldn't be. So I need to activate this later. So this one must be here, right? Okay. And around this code again. Let's see what is going on. The runtime error. New line. Okay. This is interesting. This is interesting. Let's see the previous code in C++. And C++ usually, okay, the else, yeah, sometimes um, the Python index is really, really interesting. They're really interesting. So the logic is good, but for this part, just getting tricky a little bit. Yes. Okay. But anyway, so this code, all right, so it's going to work. It's going to have the perfect scores here. Okay. All right. So anybody any questions in terms of these solutions? Hello, Alex. Any questions? No? Okay. Hello, Derek. Do you have any questions?
I don't think so.
Okay, that is good. Okay, so now it's a 2:07. I guess let's have probably a little 5 minutes break. Then let's get back to this talk a little bit. All right. Okay. Good. Okay. All right, everybody. So let's get back to the seminar. Okay. Hello, Thomas. Are you back?
Yeah, I'm here.
All right. Hello, Cecilia. You're back, right?
Yes, I'm here.
Hello, Derek. You back, right?
Yeah,
Hello, Alex Tang. You're here, right?
Yeah.
Henry, Tony, Isaac.
Yeah, I'm here.
Good. All right. So let me share my screen again. There we go. So let's finish this a little bit. All right. So last time, all right. So Thomas mentioned that so these two operators should be inside the if, right? So if I do that, basically this one is outside, right? So there's disconnected here, right? So this is one very common mistake. So you want this statement inside, all right? Okay, because they're consecutive, right? They're consecutive logic here. Good. Okay, next time, if I compile this code, run this code, there will be a wrong answer here. It is because we didn't train the data properly here. All right. Okay. So firstly, I guess what we really need to do is, okay, we need to check. So if I is bigger than 0, and in the meanwhile, if the nums of consecutive data here, right? This is I minus 1, and this is I. If that is true, I guess we're going to simply just continue. And let's run this code. Let's see what is going on. We trim this a little bit, and then we solve this problem here. So accept it. Okay. But however, if we submit, there would be some problem here because there could be uh like a repeated stuff here, right? Okay, so -2 and a 0 here because we want identical here. And how would we possibly do that is we have a for like if box not in res, if that is true, then we're going to execute this code here. This will basically just check if there is no duplicate. That simply means every single subarray is going to be unique. But this is also going to be cause another problem, which is time complexity problem. I guess if I submit this one, I would almost get the perfect score probably because this is a for loop. Yeah, this is a for loop. Okay. So this is also a for loop inside. So the last two cases wouldn't pass. That's the reason. Okay, so that's the reason we don't want to use these. Okay. Uh, and how would we possibly solve this problem? So this is U-cycle level problem solving skill. So we're trimming it dynamically. So this part is very important. So usually this is a little bit U-cycle level algorithm. Okay, so this is like a little trick here. So while left is less than R, right? And in the meanwhile, nums of the consecutive data, they are the same, right? Okay. And then I'll be pushing left forward, I guess. Okay. And then I'll also check from the negative directions here. So, and the nums of R is equivalent to nums of R minus 1, and the R will minus 2. So from two different directions here. So even though this is a while loop inside another while loop, but the range itself is considered to be less than n in itself. So this would possibly solve this problem perfectly. So, but I need to implement this code before these. So in terms of algorithm, this is there are three principles of algorithm here. So first one is going to be sequencing. Second one is going to be iteration. Third one is a selection. Most people think sequencing is not important, but I would say sequencing is very important because the location or the position you put the code would possibly change the outcome here. So let's see, let's check what is going on here. If I submit this one, oh, we have shorter. Okay, so and then let's see where else I need. Maybe I just need to remove this code here and submit this again. L less than R and this one equals this L push forward. And oh, I guess probably something wrong with these. Let's see. Do I? Oh, you know what? I need these, but where do I miss? Oh, I forgot the rest period append box here. I do need these here, right? Yeah, absolutely. Otherwise, no result here, right? Good. Okay, so let's see. Oh, something shorter than that. Okay, so I guess I missed something here. Okay, so -2, 1, 1 here. Maybe I need to remove this part. So therefore, I only care about one part here. Let's run this code a little bit. Okay. Okay, so now let's think. Do I oh no, you know what? I need to do this. I need to do this later. I need to do this later. Otherwise, the previous code, this will basically affects the overall performance here. Yes, this will push it too far away, and I do that, then problem solved here. So this is the reason I don't want everybody to memorize the solutions because it's painful. Okay, you don't really want to memorize the solution. Basically, I treat every old question or new question as a new question because I want to keep using my logical thinking to push forward. And it's pretty fun to do that, all right? And you can see every time you'll be having new ideas. And you can see, okay, so for instance, I can maybe remove one of the while loop here, and I guess it's still working. It is because if this is a consecutive data, right? I mean, I would just ignore from the other side, right? So it's still working here. Good. Okay. All right, there we go. I guess this is the end of this seminar. So from machine learning to calculus and some Monte Carlo simulation, and in the end, optimization of the algorithm from the most naive way to a optimal solutions. And I can tell you, nobody would solve a problem by one try, I guess, in the most of the times, unless you memorize the solution, and then you can do it really fast. Usually, all right, it's do whatever, anything. You need to try a lot of times. And this is a science, right? It's a different trials, right? Okay. It's just like this simulations here. You need to train this model many times. So logical thinking is very important. All right. Good. All right, so I guess this is it. And thanks for everybody's participation. And we will be seeing each other next time. Okay. Bye, guys.
Bye. Thank you.
Thank you.
Or
Bye bye.
Thank you.
bye.
Bye.
Bye.